Well, hello guys, welcome back to Mr. G Physics. This is Mr. G, and if you are new to the channel, don't forget to subscribe so we can get or you can get the notification of all the videos I post on regular basis. Today we're going to start with Newton's law of motion, and in this first lesson we are going to focus on forces. To begin with Newton's law. We're not going to do any of the law, but we're starting with forces. And to start, we're going to answer the question, what is a force? So we can say that a force is a push or pull required to change the state of the motion of an object. So to change, what does the force do? Change the state of motion of an object. Say, for instance, start moving an object or stop an object that is moving already, or let's say accelerate an object. All that is what we call a force. The main symbol we're going to use to represent forces is going to be the letter F. So F is going to be the main symbol to represent forces. And something important, forces are vectors. Vectors that you learn in previous grades. Therefore, for this one to be correct, should have a symbol of the vector on top. So that indicates that this is a vector. Okay, this force is a vector, and therefore it would have magnitude, and it would also have direction. Let's move up. Direction. So this is the general symbol for a force, and important, it is a vector quantity, and therefore we must think of magnitude and direction. It is quite important. And then now something important as well, the unit, the international unit for force, the SI unit, that is the international unit for force, is going to be the Newton. That one is going to be Newton. And then the symbol for Newton is going to be capital N. This is the international unit for force, and that means for any type of force. Okay, so far so good. We know what force is, we know the symbol as well as the unit. What else? There are two main types of forces. There are going to be two main types of forces. One of them is going to be a contact force, and the other one is the non-contact force. Non-contact force. Okay? And then, as the name of this classification of forces say, the contact force, there must be a touch. There must be a touch to produce this change in the state of motion. But in the non-contact force, they do not have to touch. Does not have to touch. Okay, so that is important. Let's give one example of each. For example, example of contact force, when you're moving the force needed to move a book from one side to the other on a table. Okay, so that is an example of a contact force. An example of a non-contact force, guys, you all know. Could be, for instance, magnetic force. We all done this one in previous grades, or could be, for example, the electrostatic force. These are forces we done previously. Those forces, you do not need to touch the objects to produce that change. A magnet doesn't need to touch a metal. It can be attracting that metal from certain distance. Then what else is quite important here? What is the instrument used to measure force? And the instruments we are going to use to measure force is the spring balance. Okay, so for now we know what is force, we know the symbol of force, we know the international unit for force, we know there are two types of force, and this one is quite important. We have contact, we have non-contact force. You know that the contact force is there must be a physical touching between the objects or the object that is causing the force, the change, and then the non-contact force, they do not have to touch. Instrument to use to measure force is the spring balance. I'm going to leave you here a picture of one spring balance. We're going to be using it in experiment. And just to finish this short video, we're going to speak about the resultant force. Now, resultant force, also done previously in other grades and in other work, resultant force is the vector sum of all the forces acting on the object. We are going to be working a lot with resultant force, also sometimes called net force, is the same. So it can either be called resultant force or can be called net force. The symbol for resultant force is going to be either Fr, for example, is a vector quantity, or could also be F net, that means resultant force, or even could be the sum of the forces. Either symbol is correct and all of them represent resultant force. Okay, now what we need to know, we're speaking about vectors. So the resultant force here, I'm going to use Fr, it doesn't matter which symbol you use, guys, is going to be equal to the vector addition of F1 plus F2 plus F3 plus all the forces you are having acting, or they are acting on a specific object. And this one we're going to discuss eventually in this lesson. I think this is all for now. We spoke about force, the general definition of force. We know the unit of force, we know the symbol, we know the classification of forces, the instrument, and finally we spoke about resultant force. And that's it. So if you did not subscribe, then subscribe for the channel so you can get the notification of the next video. Next video, quite interesting. We're going to be speaking about one specific type of force. So subscribe for the channel. Don't forget to thumb up the video if you think it helped you, and I'll see you next time. Thank you for watching. Mr. G here.